Good evening, students.
Good evening, teacher.
Good evening. So, last class we had studied the basic units or the fundamental units. Those were mass, length, and time. This was for M, L, and T. So, we always use like this square bracket, and this is for dimension analysis. So, whichever problems we'll be solving will be based on M, L, and T. So, we had seen the first three basic for mass. When it was mass, this had power 1, and whenever the other two dimensions are missing or the other two units are missing, we always put the power as 0. In some places I've told you, even though you just write it as m raised to 1, it's understood that your other two were having power 0. So whether you write like this or this way, it doesn't matter. Both have the same meaning. Same way for length, we had length power was 1, and then other two was 0. Means length will be same as for distance. And then time was 1, and this 2 was 0. These were the basic one, and the remaining formulae were all derived formulae, which were using this. So it's either like area will be length into length, and volume we saw, that is length into length into length, and accordingly the powers changed. So we'll continue with more formulae today. So total around 27 are there. So continue in those columns only. So we have made some columns. This side was the serial number. Then was the physical quantity. This already I must be having, so I'm not wasting time again writing. Then was the dimensional formula, and then the unit. This serial number. So till which one we are done? Till density, no? Or till volume we are done? Can anyone tell me which was the last one done?
Density.
Density was done. Okay. The seventh one is speed of velocity. Or basically it means speed. So speed, you know that is the formula. Speed is distance upon time. Speed formula is distance upon time. So distance means definitely length. When you're measuring distance, you will be measuring its length. So length formula will have to put here, dimension formula. Length means only the L power will be 1. So this is fixed, I told you, M, then L and T. So when we are measuring distance, only the distance power will be 1. The remaining 2 will be 0. And over here, upon means you have to write it down only. Time. So time will be 1. and remaining 2 will be 0. Now we have to simplify and finally write just 1. So anything in the denominator is there, we have to always take it to the numerator. So I told you, any number you are taking from denominator to numerator, the power, the sign will change. If this is positive, here it will go up and become negative. Here if it is minus, here it will go up and become plus. So it's basically like this: m 0 minus 0, then L powers 1 minus 0, and T power will be 0. This will go up and become minus 1. So overall, it will be m is 0, L is 1, T is minus. So this is your answer for speed. How we'll write the units? Units have already given to you. For distance, it is in terms of meters upon, because there's a upon sign. Time is given in seconds. So unit for speed is meter per second. Not seen, I'll just meter per second. Or also if you take this up, like this it is. Whether I write like this or like this, it means the same. If I take this up, power will become minus 1. This or this, whichever way you want to write. You want to take the denominator up, always change the power and key. This is the best option to write. First one. Then eighth one, acceleration. Now speed was what? How much distance you are covering in that much time. Now, acceleration is how much you are changing your speed within that much time. Means what? I'll give an example. Velocity means speed. Change in velocity upon time. Change in velocity means now you consider you are riding a bike. Okay. So if you are keeping 60 this speed, whenever I'm saying I'm riding at 60 speed, okay, it means what? You are keeping it constant. Okay, you're not changing your accelerator. You don't have to change your speed. You have to go constant at this only. So till the end, if you are going at that much, till 1 kilometer, you are traveling this much speed only on your meter, basically keeping it 60 only without changing, then that is speed. Okay, that you are covering within that much time. Now, suppose suddenly you make your speed as 20, then after that you change it to 40, you make it to 60. So again you brake, when you apply brake, again you bring it back to 20. So what is happening within that 1 kilometer or 1 hour, wherever you're traveling, within that 1 hour, you are changing your speed again and again. Okay, so whenever your speed changes, that is called as your acceleration. So that's why when we are riding a bike and all, we say accelerator, because the accelerator is used to change your speed, to change the velocity in given time. So that's the difference between speed and acceleration. Speed means constant, it remains same throughout. In acceleration, it will change. Now, We'll write the dimensional formula. The change you don't have to worry. Just look at it. In short, it is velocity upon time. So write the velocity dimension here. So here only we are direct. So velocity dimensions are here. M0, L1, T minus 1. And then time. Time is easy. Just time will have 1, rest will have 0. Now calculate and tell me the answer. What will be the final answer? Take the powers up. From the denominator, take the powers up. If you are not understanding something, you ask any substitutions you have not understood. The formula is fixed. Acceleration is velocity upon time. The velocity dimensions here only I have. So I put the velocity dimensions. In time already I know from the third one. From serial number 3, time is what? This. So for velocity I put velocity dimension. For time I put time dimension. Now calculate and tell what will be the powers. How much time you are taking?
M is to 0, L is to 1, and T is to minus 2.
Yes, because this 0 minus 0 will give me 0. Then this will be L 1 minus 0. T will be minus 1. Again, if this goes up, it will be minus 1. So minus 1 will give me minus 2. And now unit will be, just see this. Change velocity's unit is what? Meter per second. Upon what is the times unit? Second. Don't cancel like this. In the basic mathematics class, I told you, you simply cannot cancel like this. Only if it is alternate, you can cancel. So it means what? Like S upon 1. And then this will reverse. It will be M to 1 by S. Right? M upon S square is your meter per second square will be your unit. Unit of velocity I put from this. That is M upon S. Time always is measured in seconds. If you cancel like this and write in meters, it will become distance. This, if nothing is there in the denominator, it is always taken 1. And when it goes up, it will become reverse. So S into S will give me S. So meter per second square is the unit for acceleration. Ninth one. Momentum. Momentum in 10th standard also you must have studied. It is nothing but mass into velocity. Means what is the body weight? Again, the word weight we will not use because I told you the difference between mass and weight. Like how much your body weighs, okay, into velocity. It's like whenever there's an accident, if there's a big car and there's a small bike, and if they are traveling at almost the same speed, this one is also traveling at 60 kilometers per hour, this one is also 60 kilometers. So what is going to happen? This will be suppose 100 kgs. This is 10. So it's always multiplied the mass into velocity. So the momentum here will be 6000. and here this fellow will be 600. And whose impact will be more? This one. So this one will get crushed. Why? Because the momentum of this whatever vehicle is more. Why? As per the formula, it's mass into velocity, so it gets multiplied. So that's why normally the bigger ones always have more impact on the smaller thing. Okay? So that is actually what momentum is called. Mass into velocity. It's like kind of impact, how much impact will be there. Same way we have seen if we fire a normal bullet also, even where the mass is very small of the bullet, but when you fire from the gun, it will be at such a high speed that when it hits, the momentum is very high because the velocity is very high. So even a small number, if you multiply by a very big number, okay, this may be just 10 grams, but the velocity at which you will be shooting will be very high. That's why the impact will be very high, and that's how you'll get a very high impact on whatever target you're putting it on. So it doesn't depend only that big body has to be there. Even the body can be very small, like a bullet, and velocity can be very high, and momentum will be very high. So one of this should be very big, then overall momentum becomes big. So this is what we are talking about, the impact. So how the impact matters based on the momentum. No one will ask you the definitions and all. Only if you know the formula, that's more than enough. This is just for basic information I'd explain. Mass into velocity. So you know the dimensions for mass. This is 1, rest are 0, and velocity just now which we derived. M0, L1, and T minus. Why? There's a multiplication sign, so this will also be multiplied. Now it will not go to the denominator. Now what is going to happen? Now whenever it's multiplication, powers are always added. Whenever it was division, it was minus. So we have to just add the powers because it is multiplication. So this will be M 0 plus 0, L will be 0 plus 1. Now here be careful. This is already this. Don't write like this and keep. This is already minus 1. So 0, middle sign is plus, and this one is minus 1. So it's like whatever is the power, middle sign is plus. So 0 plus of minus. This you can skip, already if you know. You can straight away write it as 0 minus 1 also. But those who don't know the basic things, I'm telling you, the middle one is always plus. And then for 0, you are adding minus 1. So 0 plus into minus will anyways give me minus. That's how you'll get.
Teacher, for M it's 1 now.
1 second. Wait, which one I had written? For velocity, no? 1 second. Here. Yeah. 1 plus 0. By mistake, I wrote it as 0. 1 plus 0. Then this will give me 1. L will be 1 and T will be minus. And now write the unit. Something? Someone said? No, it's correct, no? So this will be mass will be, you can write the unit now. Can anyone tell me the unit? What is the unit for mass? Given already. In second. Yes, kg, and then into velocity is this, so that is meter per second. This is the unit for momentum, kg meter per second. Kg into meter per second will give me kg meter per second. No need to write this multiply sign, you can directly write like that. The next one, 10th one, 4. Force everybody knows, mass into acceleration. At what this it is the changing. F is equal to ma, we have studied this. Force is mass into acceleration. So put this dimension of mass and put the dimension of acceleration. M L T. So dimension, this is 1, rest are 0. And acceleration, in 8th one we have already derived. You can just put that M L T is 0, this is 1, and this is minus 2. Now add the powers. So this will be M, 1 plus 0, 0 plus 1, and T. 0 minus 2 will give me minus. It's the same concept, 0 plus of minus 2. So straight away that sign will come, 0 minus 2. Then write the units. Mass means kg into this one's unit, acceleration, meter per second square. So kg meter per second square. Okay, which can also be written as Newton. Force normally expressed as Newton. Okay, you can write N also. Force normally we indicate by N. The unit for force will be using as N. Although this is also correct, but for this general term is there, that is N. That is work. Work, we know that how much force we apply into displacement. Displacement means, in short, it is distance. Change in distance. Because we have learned before also, if you simply hold a big a block on your head and stand at one place, that is not called work. Only if you are moving with the block on your head to a certain distance, then only it is called work. Even if you stay at one place constantly with 10 kgs on your head, you're not doing any work. Only when there's a change, there's a displacement from, if you're moving from one place to another. So into displacement is formula for work. What is force? Put the dimensions for force, and distance means your length. Distance, displacement, length means same. So that will be your first one. Length means only L will be 1, rest will be 0. So calculate, and someone can tell me the answer. Anyone who still doesn't know substitutions part, what has been going on, please ask them. Calculate. Just add the powers. M power will get added to M power. L power will get added to L power. Minus 2 plus 0 is minus 2. Tell somebody. Simple ones there.
M1 L2 T minus.
Yes. So this will be this, and this power will add. L and L power will add. T and T power will add. That will be M1 L2 minus. That will be our answer. And work unit is joules. And straight away remember, given in joules. Joules, but the letter used is J. Next one. You have to remember this formula. What is work, force into displacement and all that. Energy half mv square. Energy means the capacity to do work. You can keep it stored in various forms. Okay, any work you want to do, definitely you need energy for that. This is the capacity to do work. If you are storing water also in a tank on a height, various forms of energies are there, potential, kinetic and all. So suppose in a tank, if you are filling water and keeping it on a height, then it is called potential energy. Suppose if you open that tank and then the water is flowing down, then that is kinetic energy. Like that, there is chemical energy also. When you have batteries at home, you put for the remote, they have chemical energy stored inside it. So when you start using, then the energy gets converted into whatever required is. So various forms of energy, basically the formula is half mv square. So whenever we are calculating the dimensions, these numbers will never have dimensions. They are like pure constants or coefficients. Okay, so don't consider this number. Half you can just ignore while calculating. Whether there was 5, 10, any pure number is there, just ignore. Just put the dimension for m. Now this is v square. You can also be written as what? M into v into v. There are two ways. This way also I'll take, this way also. If you are putting, first we'll try this. So put mass. For mass, dimension will be 1, this will be 0. What is velocity dimension? m0, L1, t minus 2. No space here, just write. I'll use the power square. Whichever method you all want to use, you can follow. Huh? This is, I'm using the first one. There's a square, so velocity square I put. So this power will first square will multiply to all the terms. So I told you x raised to a raised to b is always a into b. So this 2 will get multiplied to all the terms. How is it going to look like? 0 into 2 will be 0, and 1 into 2 will give me 2. This will become minus 4. This was already minus 1, no? Just correct this, huh? Then it will become minus 2. This is the velocity dimension. So 1, this will give me minus 2. And now add the powers. So 1 plus 0, 0 plus 2, no, m1, L2, t minus 2. So this is your answer. This is minus 1. This is velocity dimension, a whole square. So multiplied all the powers, then added m power to m, then got the answer. Energy unit is again joules. Put the energy unit as joules. So this I had explained using this form. You can do this way also if you get confused with powers. I'll show you this one. So this will be half m into v into v. V square can be written as v into v. So half anyways I told you, no need to write. Write the mass dimension, then the velocity dimension, again the velocity dimension. And now all the three powers will add. So it's like all a multiplication, no? So straight away add all the three powers. Then L will be, and then T will be. In both the cases, whether you solve squaring and then adding or splitting like this and then adding the powers, you'll get the same answer. So you follow whichever you want. Any doubts in this, you can ask. Then the 13th one. Power. Power is nothing but how much of work you are doing in given time. Put the dimensions of work now. In 11th one, we have already solved the dimensions for work. Just try those work dimensions. And time dimension will be, this will be 0. Now take the powers up and calculate. So whenever it's division, this will go up. This will become minus L2 minus 0. Without showing this also, those who are okay, no, directly calculate in your mind and write your answer. T minus 2 minus 1. M1 L2 T will be minus 3. And unit is W. W is for watts or watts, however you want to pronounce. Okay. Hundred watts ball. Like that we say, no? Next one. Pressure. Pressure, we know that is force upon area. Let's see if someone can calculate and tell me the answer. Put the dimensions of force, put the dimensions of area. Force is already there in 10th form. Serial number 10. We have already calculated force. Area we have already calculated in serial number 4. Just put the dimensions, calculate and tell me the answer for pressure.
M1 L minus 1 T minus 2.
Yes. Because for force it is M1 L1 T raised to minus 2. Area is length square. So this was 2, this was 0. Now take the powers up. So 1 minus 0 will give me 1. Then this will be minus 2. And then you can get it as M1 L minus 1 and T minus 2. Minus 2 minus 0 will give you minus 2. The unit is force upon area, no? So the unit for force is newtons and for area it is meter square, or also called as PA, that is for pascals. Pressure can also be written as pascals. Newton per meter square or pascal. Next one. torque. Torque, the difference is what? I'll tell you what is torque. If you have a piece of any paper or anything, if you are putting a straight force on it, okay, what is going to happen? This fellow will move ahead. They will reach her. So this is called as a linear force. Same like how you are pushing your table. You will be putting a straight force and the table will move forward. So that is a linear force, normal force which we have been studying. Now torque is something, consider on the same paper, you are putting one force here and one force here. So what it will happen, this fellow will try to push it down, this force, and this force will try to push it up. So what will happen, this will start rotating. Okay, if you are trying to push this side also, so it will continuously keep rotating. So that torque is nothing but like a rotational force, or the force which makes the object to rotate. Same like opening of your bottle cap, or even when you are driving a car, the steering, if you want to apply. So both the hands you will apply, and then one upwards and one downwards. And then the steering will start rotating. So torque is nothing but a force which will for rotational motion. You have to apply two perpendicular forces and then it will rotate. So the formula is force which are applying for a certain distance. Force into perpendicular distance actually. Perpendicular. That perpendicular will not actually make any difference while calculating the dimensions. So basically you should know force into distance. So the formula for torque is force into distance. So put the dimension of force and put the dimension of distance. Force you will get from serial number 10. And distance is for the first one. Distance means length. Sometimes they might not write this one, okay? In textbooks and all, you might come across like this letter. If this letter, nothing is there on top, means the power is 1. And if the letter itself is missing, then the power was 0. So the answer is M1, L2. And this is Newton meter. Force is Newton, distance is meter. So Newton into meter is the unit for torque. Next one. Impulse. impulse is like the effect. Suppose if a footballer has a football, okay, and then he kicks the ball. Obviously, the ball will move because there's an impulse. He's applying force at certain time. Okay, so that's called an impulse. Whenever we kick something, definitely will have some impact on it. That's called an impulse. If you go and kick a ball, your leg will pain because the impulse was on you then. Well, definitely the ball will not move. So whatever it may be, on whom it is, but there is a effect. The moment you apply some force at some time on something. So that's impulse. So the formula for force for impulse is force into time. So put the dimensions of force, put the dimensions of time. Anyone still finding difficult to add powers, you can tell, huh? Obviously, now force means Newton and time means second. Newton into seconds is the unit. Seventeenth one, stress. Stress is nothing but force upon area. Same like pressure.
So what is that? NS.
Units now for impulse, I told you. Force means Newton and time for second.
Oh, okay, thank you.
Stress and pressure, same formula, okay? So stress is same like pressure. When you have a sponge, okay, so when you apply some pressure, what is going to happen? It will shrink. So this is the stress because you're applying some force on that particular area. So put the dimensions of force, put the dimensions of area. Force is here on this. Area means L square. Rest of 0. So this will be 1 plus 0. Already 1. When you take this up, it will be minus. Minus 2 is already present. It will work 0. This will be M L minus 2. And then just write the unit here. Force means Newton upon area means meter square. So that is the unit for stress. Newton upon meter square. Right at the side, okay? In the next call. So that's why these are called as derived units. Because you need the basic ones and then you keep on complicating it by using different formulas. Next one is strain. Eighteenth one is strain. Strain is change in length upon original length. What basically it means is how much effect was there on the this. Consider you had 10 centimeter sponge. Then you applied some pressure. This got shrunk, okay? Became smaller. Suppose it became 8 centimeters. Now how you would calculate strain? How much did it go how much did it change? 10 minus 8. Okay, how much did it become reduce? And then upon length would have been your original length 10. It would have been 2 by 10. So that would be your strain. So basically it is nothing but change in the length because of the impact upon its original length. How much was it before the pressure and how much did it shrink after the pressure? So it got shrunk by two units, whatever, whether it was centimeter, meter. So basically it is length upon length only. So this words I told you, change in velocity, this you don't have to bother. Look for the unit. This is also length, this is also length. So numerator also length only dimensions I have to put, denominator also length dimension. And then calculate. 1 minus 1. So if you notice, everything will be 0. So it doesn't have any dimension only. The strain is the one this which is dimensional. Okay, strain doesn't have any dimension, so that's why it is called as dimensionless. To pronounce also it becomes so difficult. Dimensionless. Because length and length will cancel out each other, nothing is remaining only. So it doesn't have any unit. No unit, because meter upon meter, length will be in meters. This length also will be in meters. It will cancel. There will be no unit left. So that's why no unit for strain. Any doubts in this? You can ask. Coefficient of elasticity. All these terms now you will understand in detail when we go as we move on to the chapters later on. Okay, now obviously I cannot sit and explain you the whole chapter. I'm just giving you a rough idea like what exactly it means. Stress, strain. Now coefficient of elasticity will be stress upon strain. So you will come across different coefficients. Means when you calculate a stress and strain, you have to divide and then you'll get a number. Because how elastic that particular thing is, how much can strain be put. Like different objects will have different coefficient of elasticity. A rubber band you can stretch to maximum. Okay, so that will have a different number for elasticity. Then a paper, if you try to put, that will tear at some point. And if you try to stretch some wall, obviously it is not that possible because all the objects have different coefficient of elasticity. And how do you calculate that? By first calculating how much stress you are putting on that and how much can it change. Like the sponge I told you, how much stress you can put and how much can it shrink, and that will give you a number. So basically just remember what is coefficient of elasticity, stress upon strain, then put the dimensions of stress. Put the dimensions of strain. Even if you don't put it, is okay because you know that it doesn't have dimensions on it. Whether you substitute this or don't, it will not make any difference on your calculation because all are anyway 0. So it will remain the same because 1 minus 0 will be 1. And therefore the unit will be same as stress only, Newton per meter square. Next one. Surface tension. This also will come across later. In 10th standard also you must have seen this. Like why things will float. Okay, on a when you put a paper this paper boat on a why it would float. Or suppose even if there's a bubble, like you'll get certain amount of this water if you try to put, it will not start flowing instantly. It will make a small just like. So why does it hold and all because of surface tension. Anyways, we'll study that in detail later. Surface tension is nothing but force upon length. The formula for surface tension is force upon length. So put the dimensions of force and then length. One minus one will become 0. The answer will be and force upon length will be nothing but force means Newton. Just write the unit at the side, and length means meter. So this is the unit for surface tension. Next one is frequency. Frequency you know is 1 upon time. Means how many times something can occur within that much given of 1 second or whatever. So it's like if you have any wave like this, it will come across like this also. And I want to know what is its frequency for this particular time. So I have to check how many times it's been repeating. 1, 2, 3, 4, 5, 6 like that. So basically, how to calculate is 1 upon 2. In the terms of definition, it is how many cycles it will repeat within that much given time. Whether it may be 1 second or whether you're calculating for 10 seconds. So 1 upon time means this will be 1 only. Time you put. So we will never keep anything in the denominator as my final answer. So the whole thing will go up. If nothing is there means, you know that 1 upon x raised to a is x raised to minus a. This will go up and become minus 0, which actually doesn't make difference whether you write minus. But this is important. T will go up and become minus. Your dimensions is 0, L0, T minus. The unit for it is 1 upon time means 1 upon second. If you take it up, it will be like this. Or also frequency is given in terms of hertz. Hertz. This word. ATR They can write it as 1 upon second. That will go up and become second raised to minus 1 or hertz. Okay. Velocity gradient. Velocity gradient means how much the velocity has been changing within a small distance. It's like if a river water is flowing, okay, not necessary at this, if there's a height like this, the water is flowing, the speed of this particular water in this distance will be different. At this point, it may be different. At this point, as the slope and all, it will be different. At every point, it will change. Okay, so that change when you try to calculate at every single distance, certain distance, that is called as a velocity gradient. Means how much your speed is different at different distances. So basically, the formula is velocity upon distance. So write the dimensions for velocity and then distance. So this will be m0. This will also become 0, 1 minus 1, and this will be minus 1. If you want to calculate the unit, just do this in the rough work. There you will not be able to see, that's why I'm writing here. Velocity is what? Meters per second. Distance is how much? Meters. And now this alternate you can always cancel. Because nothing is there means it is 1. So it's like m into this into 1 upon m. And then it will cancel. This is a longer method by taking reverse. So basically m and m will cancel. So what remains is 1 by s. So your unit for velocity gradient is 1 upon s. How you get? Put the unit of velocity, that is meters per second. Put the unit of distance, that is meters. Then m and m will cancel. What remains is 1 upon s. Same way you have pressure gradient. Same like velocity. Now if you have pressure, then it will be pressure upon distance. So substitute the dimensions of pressure and then substitute dimensions of distance, then calculate. Pressure is these are 0. 0 then specify. If you keep blank, it is assumed and it is 1. If you don't write the power, then it will be assumed as 1. If the power is 0, just specify. Otherwise, not write only the letter. You can do like this also. And now calculate. This will be m. Minus 1 will give you minus 2. Then calculate the unit. This is Newton upon meter square. And unit for distance is meter. Here you don't cancel now. What is going to happen? If nothing is there, it means 1. So Newton upon meter square will become volta and become 1 by m. If you cancel like this, it will be wrong. So m square into 1 will give me m cube. So n upon m cube is your unit. This is the unit for pressure. This is the unit for distance. If nothing is there, you have to take it as 1 and then reverse it. And 24. Moment of inertia. This word you all must have heard before also, that this example of bus. Suppose if you are sitting in a bus, okay, and the bus is moving. Suddenly, if the bus applies brake, okay, you tend to fall. And in which direction? In the front direction. Why? Because what was happening is your body was moving along with the bus. So even the bus stopped suddenly, but you still continue to move at some point. Suddenly this fellow applied brake, but it was like your body was still moving with that speed. So your body came to take a halt. So till then that jerk is there. Okay, and that is because of the moment of inertia. So whenever you apply, so the bus will stop in the backward leg whenever they apply this brake, it will stop. But this is always you have opposite force. So you are moving in the forward direction along with the bus. Next time you will fall in. So it's like a continuous motion, okay, along with the bus. So that is moment of inertia. So it's but in terms of formula, suppose mass into distance square. This is the formula for moment of inertia. Mass into distance square. To put the dimensions of mass, these are simple. Mass means only m will be 1, rest are 0. Distance means only length will be 1, rest will be 0. Distance and length means the same. And there's a square. There's a power square. So first, don't add first and then square. Huh? This power belongs only to the second dimension. So first square. Don't add this like this and then the whole square. This is separate. First solve this. 0 into 2 will give me 0. Then 1 into 2 will give me 2. And t into this will give me 0. You have to multiply basically. Don't do 1 square. It's 1 into 2. And now add the powers. Unit is simple. Mass means kg. Distance means meter square. Next is potential energy. Potential energy, I told you, is nothing but kept it in the stored form. You store it and keep. And the formula for that is mgh. This is mass. G means gravity, or you can say acceleration due to gravity. You can write this G on top of the page and keep if there's no space. G means acceleration due to gravity and h means height. Height means obviously it is length or distance. Acceleration due to gravity means what? Obviously potential means you are keeping it at a height and this is your ground. So anything you release, if it's falling off, so there will be gravity which will be applied, because on the earth definitely there will be a gravitational force which will be acting upon this. Basically forget about this gravity, whatever it may be. Main our consideration is acceleration, mass and length. So put the dimensions of mass, put the dimensions of acceleration, and put the dimensions of length. All the three will come. So mass is acceleration. You put the dimensions and then length. Acceleration is there. Eighth one gets solved. m0 L1 in t raised to -2. And height means length, rest will be 0. And now add all the powers. All the three powers will get added because all are multiplication. 1 plus 0 plus 0. Then L 0 plus 1 plus 1 T minus 2 the answer is M1 L2 T minus. And energy I told you joules. And write it as J. Unit is J for joules. Any energy will be measured in terms of joules. And these two are extra ones. Just write in and keep. In some problems you may come across this. Like this, how we have derived, no? Now, whether if you know the formula, definitely you can put the dimensions and calculate for any unit. Like that, if any other formula also comes up, you should know how to put the dimensions, calculate and write the answer. You'll be solving many problems based on this. And even for exam point of view, mostly 5 out of 5 marks, 4 marks will be definitely problems. Only 1 part mark can be theory. Of entire 5 marks will be problems. Just the 26th, 27th one is just write and keep. One is Planck's constant. Just write only the directly this and keep. H it is denoted as. This is the dimension. It's directly a constant, okay, the fixed value. One more is the Young's modulus. Y is equal to so these are all the units and their dimensions. We have seen how to calculate. Just revise them again and again so that you know, because every this you should be knowing the formula and how to derive. No one will give you ready-made on this one is this. So you'll have to know the formula and then calculate. Next class we'll start with the problems. I'll stop here. I'll take attendance.